One of the possible methods to solve for w in this equation is to let w assume the form of x plus I, y, which means that rather than solving for w directly, we will solve for x and y in this equation. On the left hand side, let's do a binomial expansion. So on the left hand side, it is going to be a x to the power of 3 plus 3 choose 1, which is 3x squared of I, y, plus 3 choose 2, which is also 3, so 3x of iy squared plus iy to the power of 3. This is equal to 27. So we have x to the power of 3 plus 3i of x squared y. I squared is negative 1, so negative 3x of y squared, and I to the power of 3 is negative I, so negative I y to the power of 3. This is 27. Let's try to group all the real portions together. That will be x to the power of 3. Then we have a minus 3xy squared. And if I were to group all the imaginary portions together, we have a 3x squared y minus y to the power of 3. This is equal to 27. And just like how we have done the previous question, 27 we can see as 27 plus 0i. So if I were to match the real to the real portion, we have a x to the power of 3 minus 3xy squared. This is going to be 27. And we have a 3x squared y minus y to the power of 3 is equal to 0. As for this, we can actually factorize. It will be 3x squared minus y squared is equal to 0. Factorizing it even further, we have a square root of 3x plus y and square root of 3x minus y. This is equal to 0. So y must be equal to 0, or y must be minus square root of 3x, or y must be square root of 3x. And I'm going to substitute these three possible expressions for y back into the first equation that we have here to solve for x. So when y is equal to 0, substituting it inside here, we have a x to the power of 3 minus 3x times 0 is equal to 27. So it is like having x to the power of 3 is equal to 27. And this gives me x to be equal to 3. Which means that the possible value for w is going to be equal to 3 plus 0i, which is 3. And this is not what the question is asking for, because this happened to be the value of w that the question has given us. And the question wants other possible values, which means that it is probably going to be obtained from either here or here. I'm going to be substituting these two into this. And since we are replacing y squared by this, so it doesn't really matter whether it is negative or plus. So I'm going to do it together, which means that I'm going to let y be plus or minus square root of 3x. And substituting this back into here, we have a x to the power of 3 minus 3xy, which is plus or minus square root of 3x squared. This is equal to 27. And this will get us a x to the power of 3 is equal to minus 27 over 8, which means that x is going to be equal to minus 3 over 2. And when x is minus 3 over 2, if I were to replace x by minus 3 over 2 here, that means the corresponding values for y will be plus or minus 3 square root of 3 over 2. This gives us the two other possible values for w. One is going to be equal to minus 3 over 2, then minus 3 square root of 3 over 2i. And the other possible value for w is going to be minus 3 over 2 plus 3 square root of 3 over 2i.